Hi everyone! In this video we're going to look at problem D on page 47. D says 3 minus 4 sine squared equals 0. Now, you might have already noticed, this problem has a lot more going on in it than these other problems did. So the goal is to make this equation look something like this, kind of like what we did in problem B. In problem B, remember we had to subtract 1 on both sides in order to get cosine by itself. In this case, we have to do a few other things, because there's a lot more going on in this one. Notice that there's a 3 being subtracted to sine. Sine is also being multiplied by 4, and sine is squared. So we need to somehow get this equation to look like one of these problems. So I'm going to go ahead and write this problem on the other side of the worksheet, because I'm going to run out of space if I don't. So let's go ahead and write it over here. So D, that's 3 minus 4 sine squared equals 0. Okay. So the first thing I'm going to do is change sine into a variable, just to make this problem look a little easier. So I'm going to rewrite sine as y. So y equals sine. Again, I'm just doing this to make this problem look a little easier when we go ahead and solve it. So let's rewrite it as 3 minus 4. Now since I replaced sine with y, sine squared is now going to be y squared equals 0. Now do you see how this equation looks a little bit easier to solve than this one? We've kind of seen these problems before. Just 3 minus 4y squared equals 0. The goal is to get y by itself. So the first thing we want to do is get rid of the 3 here. To do that, we can subtract 3 on both sides, because what we do to one side of the equation, we must do to the other. 3 minus 3 is 0. That cancels out. We can bring everything else down, so we get 4y squared equal to 0 minus 3. Remember that 0 minus 3 gives us negative 3. Okay, so now we want to get rid of the 4. 4 is being multiplied to y here, negative 4y squared. So to get rid of it, we can divide both sides by 4, or negative 4. Then negative 4 divided by negative 4 gives us positive 1. So 4 cancels out, and we're left with positive 1, or 1y squared, or just y squared, since 1 times y squared is y squared. So we're left with y squared equals, remember that a negative divided by a negative gives us a positive number, so we're left with positive 3 over 4. Okay. Now we need to remember, how do we get rid of y squared to just be a single y? How do we get rid of the 2, the power? In order to do that, we can take the square root of y squared. And what we do to one side, we also must do to the other side of the equation, so we have to take the square root of 3 over 4 as well. Now let's just remind ourselves, how do we take the square root of a number? Remember that y squared can be rewritten as y times y, because y squared is just the same thing as y times y. Remember that when we have a square root, the index is 2. So we're looking for 2 of the same number, or a pair, which we have here, y and y. That tells us that y comes out of the square root as just a single y. So y equals, remember when we're taking the square root of a number, when we're solving for a squared variable, that number will be plus and minus the square root of 3 over 4. But also remember that when we have a fraction and we have a square root, we can put the square root on the top of the fraction and the bottom of the fraction and write it individually. In other words, we can write it as the square root of 3 over the square root of 4. Now we need to simplify both. Now, what numbers multiply to 3? Just 3 and 1. So we can't really find any pairs here. So we're going to have to leave that alone, square root of 3. But what multiplies to get 4? 2 and 2, right? And that's going to give us a pair. So that means that 2 will come out on the bottom. So our y is going to equal the square root of 3 on the top and 2 on the bottom. So y equals the square root of 3 over 2, plus and minus the square root of 3 over 2, since we're solving for a squared variable and way to square root. Okay, now it looks like we're almost done, but remember that y was actually sine. So now we need to replace it back in order to finish this problem. So I'm going to turn our y back into a sine. So now we actually have sine equals plus and minus the square root of 3 over 2. Okay, now how do we finish this problem? Now it's kind of like what we've seen before. What angle makes sine equal to positive square root of 3 over 2? And what angle makes sine negative square root of 3 over 2? So we have two cases then. We have a case where sine equals positive square root of 3 over 2, and where sine is negative square root of 3 over 2. So let's look on the unit circle and figure out where sine is positive square root of 3 over 2. Remember that sine is positive above the x-axis in quadrants 1 and quadrants 2. Before I do this problem, I want you guys to try it on your own. Find an angle that makes sine positive square root of 3 over 2. And if you manage to do that, then try to figure out what angle makes sine negative square root of 3 over 2. So go ahead and pause the video and try it on your own first. Okay, so let's come back. So like we were saying, let's do the first case first. Positive square root of 3 over 2. Sine is positive in quadrants 1 and quadrant 2. So let's see where sine is square root of 3 over 2, or our y-coordinate is square root of 3 over 2. Looks like right here, we have square root of 3 over 2 for sine. So one of our angles for theta can be 60 degrees or pi over 3 radians, same thing. But also notice that sine is positive square root of 3 over 2 right here at 120 degrees or 2 pi over 3 radians. So angle theta can also be 120 degrees or 2 pi over 3 radians. So we have two answers where sine can be positive square root of 3 over 2. Okay, now let's go ahead and look at where sine can be negative square root of 3 over 2. So remember that sine is negative on the bottom of the x-axis in quadrants 3 and quadrant 4, because that's where y is negative. So we need to figure out which quadrants, or which coordinates, is sine negative square root of 3 over 2 in. It looks like sine is negative square root of 3 over 2 right here at 240 degrees or 4 pi over 3 radians. So theta, our angle, equals 240 degrees or 4 pi over 3 radians. Also notice that sine is negative square root of 3 over 2 right here at 300 degrees. So our angle can be 300 degrees, which is the same thing as 5 pi over 3 radians. Okay, so notice that we actually ended up with 4 answers. This problem was a little bit more difficult than the other ones we've seen so far. But that's problem D. In order to get, just as a review what we did, we wanted to get the trig function and a value. So we need to get rid of the 3. We subtracted 3 to both sides. Then we needed to get rid of the 4, so we divided both sides by 4. We need to get rid of the squared, so we took the square root of both sides. Then we got y by itself, equal to plus and minus the square root of 3 over 2. Then we had to replace our y with our sign, since we just replaced it before to make it easier to solve. Then sine ended up being plus and minus the square root of 3 over 2. Then we had to figure out what angles that sine were as square root of 3 over 2 positive and square root of 3 over 2 negative. Negative 3 over square root of 2 and positive square root of 3 over 2. We found that sine was positive square root of 3 over 2, 60 degrees, or pi over 3 radians, and 120 degrees, or 2 pi over 3 radians. And we found that sine was negative square root of 3 over 2 at 240 degrees, or 4 pi over 3 radians, and at 300 degrees, or 5 pi over 3 radians. Perfect. So that's problem D. In the next video, I'll go over problem A. Until then, see ya.